how on earth are we supposed to accept a theory so wild that it's almost, by wild, I mean so that posits a universe or multiverse so different from the one that we appear to inhabit that it makes it almost impossible to believe? Does this strike you as a merited objection, or it's just one that has to be gotten over?
Well, I mean, in a sense, it's not so much an objection, but just a psychological report. I mean, you're saying to me, how on earth can I accept something that I find so impossible to believe? I mean, frankly, that's your problem.
Yeah.
I mean, we can have a conversation about its scientific merits and demerits. But if you can find some inference from, I find this theory very difficult to believe, to this theory is objectively unlikely to be true, then I'm all ears. But otherwise, that's just a sort of comment on one's capability. I mean, I find it difficult to believe sometimes. I find lots of things difficult to believe. I find it difficult to believe that we elected Donald Trump 5 years ago, 7 years ago. I find it difficult to believe that the cosmos is as big as it is, even without quantum mechanics. These things are all my problem. We've got extremely good evidence that we elected Donald Trump 7 years ago. We've got extremely good evidence of the physical size of the cosmos, and I think we've got extremely good evidence of the many worlds theory.
So, what is it then that makes it hard for you to believe at times?
I think probably just my kind of animal psychology. I mean, I use the Trump comment was just a joke. I use the relation to the physical cosmos advisedly. I mean, do you actually have a sense of how far away the sun is, even? I mean, I could quote you a number. It's 93 million miles away. Do you actually have a visible sense of what that means? How could something ever be that far away? I mean, you could sort of talk about it in terms of how long would you have to drive to get there, but really that doesn't help you understand it. I mean, my sort of vision of the scale of things doesn't really have room in it, intuitively, for something that's 93 million miles away. My brain was not evolved to handle things on that scale. It was evolved to handle distances in the tens of miles and populations in the hundreds, and timescales ranging from milliseconds up to years. Why would we expect that my cognitive capacity smoothly accepts and handles and visualizes something 93 million miles away? I have the mathematical tools to kind of get a grasp of that, but there's some sense in which my monkey brain just viscerally struggles at it. I don't think in the visceral resistance to Everett is necessarily so distant from that. I mean, there are perfectly good epistemic arguments one can have about whether the degree of observability of Everett branches is problematic or something. But as far as the straight incredulous stare is concerned, I just think it's a mismatch between human psychology and how weird physics is.
Mm-hmm. I have never thought about trying to wrap my mind around just how far away the sun is. Maybe I should have.
I mean, bear in mind also that's just a warm up. I mean, if you think the sun's far enough away, let's talk about the Andromeda Galaxy.
Right, but what I do often find myself trying to wrap my mind around is the speeds at which astronomical objects move at like thousands of miles a second. It's just impossible to wrap my mind around because, like you said, I'm built for terrestrial speeds. That's how my mind works. So the last objection or problem is, you call it the competition problem, which I again admit to being somewhat sympathetic to. And in my own words, I mean, why? I don't want to mean this pejoratively, but why settle for many worlds, which seems extravagant in some ways and unparsimonious, at least in the amount of worlds it allows, when we haven't exhausted the possibilities of quantum mechanics that don't entail a multiverse?
Well, I think it's a general question about how science goes. I mean, look, you might suppose you're Immanuel Kant or a certain slightly caricatured reading of Immanuel Kant, and it's deeply embedded in your theory of mathematics that space is Euclidean. You learn that physics is now completely committed to general relativity, in which space is not in general Euclidean, and which describes gravity as a curvature in space and in space time. And you say, well, why should I have to settle for a theory that denies the Euclideanness of space when we haven't exhausted the possibilities of theories of gravity in which space is Euclidean? And I think if you tried that line on most people in physics, they'd be a bit nonplussed. I think they'd kind of say, look, if you've got a concrete theory that's just as predictively effective as our existing theories in which space is Euclidean, let's talk about it and let's do some experiments and things. But if all you're saying is, well, look, maybe I could have some idea which would explain gravity while holding on to Euclidean space, then that doesn't seem much more than a kind of pious dream. And I think similarly, I mean, have we exhausted the possibilities of theories in which there isn't a quantum multiverse? I mean, in a certain sense, I'm sure we haven't. The cardinality of the set of theories is presumably countable infinity. We certainly haven't checked them all. But that's not normally how we think about scientific progression. Science is really rather hard. And we have, in quantum mechanics, a spectacularly successful theory. There's no real competition anywhere in science for how successful quantum mechanics is. The theory of evolution perhaps gives it a run for its money. But we've got an amazing theory of this kind. And if we have a way of making sense of that theory that doesn't involve many worlds, fine, let's talk about that way of making sense of it. And if we've got another theory comparably amazing, that's different from quantum mechanics, but just as predictably powerful, well, I'd love to hear about it, and probably so would the Nobel Prize Committee. But absent that theory, I just think it's daydreaming, really, frankly, to just say, well, we don't need to worry about the fact that our current theory seems to have a compulsory many worlds reading, because maybe we'll come up with another one some other day. I mean, to be a bit provocative, you could say the same about the theory of evolution. If you had deep religious convictions against the theory of evolution, you could always say, well, we haven't explored the range of all theories in which organized complexity comes about some other way. And then, technically that's true, but it's not really very compelling.